Right, here we are where we left off in part 2, and if you haven't seen the first 2 episodes and you want to be brought up to speed, watching them is probably a good way to do it. So the next step to getting this toggle working is making sure that it's green at the top and red at the bottom. Now your first instinct might be to use the at top property to control the color. So you might do something like this. At top, question mark, green. If we're not at the top, red. Okay, seems to make sense. So let's play that and see what happens. Okay, not bad. It's almost there, but the problem is that when we go through the midpoint, we want it to indicate whether or not it's going to finish at the top or the bottom when we release the drag. So we need another state property that is going to track that. So let's duplicate that. Call it potentially at top. Right, so let's go down to our changed function. And as well as setting the Y translation, we're going to say potentially at top is top half with the gesture. And then instead of at top, we just write potentially at top. And then if we resume this, as I drag it, it will change as I pass the threshold. All right? So that's the color sorted out. And next we're going to set our sights on scaling this thing. And what we want to do is scale it in the Y direction based on the translation. So I'm going to create another computed property and just call it private var scale for translation, which is a CG float. And at the moment we'll just return 1. Let's resume. And at this point, I'm going to introduce another computed property called the absolute translation. Private var absolute translation, which is a CG float. And that is literally going to be the absolute value of the Y translation. Let's resume and think about this logic. When we drag by a value equal to the size of the toggle, then as you can see, we need to scale the toggle by 2. If we drag by a value equal to twice the toggle size, then we need to scale it by 3. So the equation that determines the scale is going to be 1, since it starts with a scale of 1, plus the distance it's been dragged divided by the size of the toggle, which looks like this. Plus absolute translation divided by its size. Now, we're not using that at this point, so let's go down to our stretchable square. And under the frame, I'm going to say that the Y scale is equal to scale for translation. Okay, as I'm pulling it, it's not quite working. And this is because, by default, views scale from the center. So it's not remaining stuck, and it's overtaking our drag. This can be addressed quite simply by halving the effective offset for a given translation. So I can say Y translation over 2. Now let's see what it looks like. All right. There you go. So now it looks like it's stretching with the movement of the gesture, which is great. Now we can of course anchor the shape to the top, and I'll show you that approach at the end. So now it's time to use that sticky threshold that we pulled into this right at the beginning, because at the moment it's obviously stuck until you let go. So we need yet another state property here, which is going to store whether or not our toggle is stuck. And we're going to put that right at the top. Stuck, true. Okay, so now we have a property to store it. Let's actually set that property in the onChanged and onEnded functions. Being stuck is equal to whether or not the absolute translation is less than the sticky threshold. And once we finish the drag, we know that stuck is going to be true. So let's resume. And before this is going to work, we need to make the scale and translation behave correctly for whether or not we're stuck. So let's do the translation first. We're going to say, if we're stuck, then that is the behavior we want. Otherwise, we actually want to return the actual translation. And as far as the scale is concerned, so we're going to put a guard, making sure that this thing is stuck and it's a valid translation. Otherwise, we're just going to return 1. And at this point, when I drag it, we can see that it stretches up until the point when it becomes unstuck and reattaches when we let go. But you can see here that it is still reattaching to where it used to be. And that's a problem. The reason this is happening is because in our onChanged handler function, we're not accounting for the fact that once we've become unstuck, we don't want to get stuck again. So we need to put that in a conditional. So down here, we'll say, if we are stuck, only then do we potentially set stuck to false. So now we say, we've let go, and we're not going to go back again until we've released the gesture. Now, before we continue, let's put these new properties into our debug section so we can see them changing as we're performing these gestures. So let's create another couple here, potentially at top. Put that there, stuck. Put that there, and this obviously has to be in a V stack now. Like that. And as we drag this, stuck is true, but top is false. Potentially at top, you can see it changing as we're moving. So that's very nice to see. And now we need to talk about the stretch factor. If you remember, the stretch factor is a number that goes from 0 to 1. So that means that as we are dragging the toggle, it starts at 0, completely unstretched. And then as it approaches the sticky threshold, it tends to 1. So it goes from 0 to 1 and then becomes unstuck. So we need to do a little bit of mathematics inside a computed property so it doesn't clutter up the design part of the code. So we're going to scroll down here. I'm going to call it private var stretch factor, which is a CG float. And the first thing we're going to calculate is the distance that we've got to travel before we get to the sticky threshold. And that looks like this. Let distance to threshold is equal to the sticky threshold minus the absolute translation. So regardless of the direction in which we're traveling, we know that it's going to unstick once it gets to the sticky threshold, which in this case is a third of the height. And we are subtracting the distance that we've already traveled from that. So this value is going to be getting smaller and smaller. But it could be any value. We have to normalize this value to go from 1 to 0. The way we do that is actually quite simple. We've got a distance that we can cover, which is the sticky threshold. And all we have to do is divide the distance to the sticky threshold by that sticky threshold. And that looks like this. Let normalized distance to threshold is equal to distance to threshold divided by the sticky threshold. And that will give us a value that goes from 1 to 0. And you can check that for yourself with a bit of mental arithmetic. If we haven't moved, the absolute translation will be 0. So the result will be sticky threshold over itself, which is of course 1. When we reach the threshold, the value will be sticky threshold minus itself, and then divided by itself, which is of course 0. But we want the stretch factor to go from 0 to 1, then all we do is subtract that from 1, and we've got our result. So we say, return 1 minus normalized distance to threshold. So we're almost there with this stretch factor, but we want to put a guard in there because we only want it to be stretching if it's stuck and it's a valid translation. So we use the same guards as we did here, copy that, paste it in there. But in this case, if nothing happens, we don't want it to stretch at all. Right, so let's resume that. And then we can use this stretch factor in our design. All we do is we say that the stretch factor is equal to the stretch factor. But we mustn't forget that we also need to change the orientation. So we need to pass in whether or not we are at the top. We do that like this, at top. Now, if we pull this, look at that, a wonderfully stretchy toggle. We see our parameters changing, it goes down to the bottom, and when we pull up, it stretches in the other direction. We pass the center point again, and when we let go, it shoots back to the top. Okay, so I'm going to finish it there for now, and in the next episode, we're going to be doing the animations and a few other things, so join me for that. It's going to be brilliant. If you don't want to miss that and you're not subscribed already, then consider doing that, and it's more than likely that you won't. If you're liking what we're doing so far, then give it a thumbs up, which obviously makes me very happy, but also helps other people find the channel so they can follow along with us. If you have any comments or suggestions, please leave them below. But in the meantime, thanks for joining me. See you next time.